Hello and welcome to the fifth lesson in unit number 2. And today we're looking at graphing quadratic functions by completing the square. So the title kind of explains what the goal is today. I want you to be able to complete the square, which is something you've been practicing the last day or two and mastering. And now I want to take it one step further and combine your graphing skills from earlier with that. So graphing quadratic equations. So there are three forms of a quadratic function. We have standard form. And standard form is y equals ax squared plus bx plus c. We have vertex form. That's y equals a x minus, I think you're using h squared plus k. And finally, factored form. So each of these we've practiced, or you've, sorry, let me get this wrote down before, so I can explain here. So each of these you've done. Standard form is really, what we were given originally. You've completed the square. That gets us to vertex form, so you've seen it. And factored form, we've practiced factoring, so you've also can look at that. So those are our three forms for a quadratic function. Now, each of these functions, we write each in that other form. So if we look at the example here, y equals 8x plus 12. I'm going to do this quickly. You don't have to do this out long. I'll speed it up here. We write in factored form, which is x plus 6 and x plus 2. So there's your factored form. Or we can write it in vertex form, which would be x then x plus 4 squared, and then I think it comes out to be minus 4. All right, so I skipped a bunch of steps there, but I'll show it in more detail. But there are your three forms, okay? So you have your standard, you have your factored, and you have your vertex form. All right? Each form plays an important role. All right? So pros and cons for standard form. Pro, easy to put into technology. All right. It enters into a lot of the graphing software with little difficulty. Easy to find the y-intercept. All right, because that's always your c value. All right, oops. Your c value is always your y-intercept. All right, so you can just take a look at the function and know right away what the y-intercept is. All right, our cons, difficult to graph by hand. The only real way to do it by hand is to create a table of values, which is not desirable if we can avoid that. All right, so time and place for that standard form. Now factored form, pro for that, easy to find the x-intercepts. Okay, we can find the x-intercepts really quickly in factored form. Easy to find the roots, which is the same thing. That's when we're solving, setting an equation equal to 0 and solving. The cons, can't find the vertex. Vertex as easy. You have to do a little bit of work for that, and we'll see that a little bit later on. But factor form is pretty useful. And finally, your vertex form. The advantage to your vertex form, it's easy to graph from. Oops, easy to graph from. Easy to find the vertex. Easy to find max min. And that's something that we'll be talking about in a little bit. All right, so you can easily find that piece of information. The con to it, the downside to your vertex form, tough to find x-intercepts and y-intercepts for that matter. All right, it's possible. I'm just saying it's not as easy. It looks like touch. Let's try that. Tough to find x and y-intercepts. So you can see that each form has a specific role, so it depends on the situation. If I want to know the x-intercepts, factored form is where I want to be. If I need the vertex, I got to go to vertex form. If I'm just putting it into software, I don't really care, but standard form's kind of nice because a lot of the software expects you to put it in standard form. All right, so the focus today is completing the square and graphing it. So we're going to go through an example as to how we go about doing it. All right, so just getting room for myself. Completing the square, you've been practicing this. We factor out any common factors in the first two terms. So I'm going to take a 2 out. That leaves me with x squared plus 10x. Leave the 32 alone. Next, I'm going to complete the square inside the bracket. So that means I need to take that second term. I'm going to divide that by 2. That gives me 5. Square it. I get plus 25. But to keep balance, I have to subtract 25, and that keeps my balance. Plus 32. Those first three terms will always make a perfect square. So that means we'll have 2 bracket x plus 5 squared. Now you got to remember that that 2 multiplies that term we did not use because this guy's not part of the perfect square. So we end up with negative 50 plus 32. Final answer is x plus 5 squared. Negative 50 plus 32 is, that's negative 18. Okay, so what information do we know right away from our vertex form? Well, the vertex form kind of says you know the vertex, and it's going to be at negative 5 and 18. Secondly, and this is the other piece of information, in order to graph this by hand, we know the step pattern is 1, 1. So over from the vertex 1, up 1. Over from the vertex 2, up 4. Over from the vertex 3. Then we go to the right 9. So we talked about that when you were doing your graphing. We take those values and multiply by our A value to get our new step pattern, which would mean it would be over 1. In this case, A is 2, so it would be over 2. Then it would be 2, 8, and 3, 18. So there is our step pattern that we need in order to graph. Okay. Now let's go ahead and graph it. So we know the vertex is at negative 5 and 18, and of course, looking at the graph, it obviously won't go up to 18. So let's double everything here. So instead of going up by 1s, let's go up by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, just to make life easier. So negative 5, 1, 2, 3, 4, 5, 18. So here's my vertex. All right, so I'll put a V there for vertex. Now, this is, hey, negative 18. I'm sure a couple of you have been saying, why is it not negative 18? The answer is because I didn't copy it down right. Sorry, vertex then would be down at negative 18. My fault, sorry. So there's our vertex. Our step pattern, I'm going to go over 1 and up 2. So remember, every square is worth 2 on my new y-axis. The next one, from the vertex, I'll go over 2 and up 8. 1, 2, 2, 4, 6, 8. Symmetrical. Now I'm going to go back to the vertex, over 3, up 18, which will take me back to the x-axis. So there we go. There is our parabola from start to finish. So going from standard form all the way to a final graphed product. Okay, I have one more example here. I always like to throw a fraction or a decimal one in or a fraction one in, just to remind you. So again, here we go. We common factor out from the first two terms. So we get 0.5, and in brackets it'll be x squared plus 3 divided by 0.5. That's like 3 times 2. So it'll be 6x. And again, let's leave that last number alone. Let's create our perfect square. X squared plus 6x. Take that middle term, divided by 2 is 3. Square it is 9. Whatever you do, you have to do the opposite to keep the balance. Those first 3 terms create our perfect square. So we have 0.5 and this will become x plus 3 squared from our factoring. Please remember that 0.5 and the last number need to be multiplied together because we're not using it. So it'd be negative 4.5 minus 5. Final answer, 0.5 x plus 3 squared minus 9.5. So again, information. This time I'll write the vertex down properly. Negative 3 and negative 9.5. So there's our vertex. Next we have to find our step pattern. So this is something you'll have on your cheat sheet probably. Oops, hopefully not that. 1, 1, 2, 4, 3, 9. Those step values we're going to multiply by our A value, which in this case is 0.5. So it'll be 1.5, 2, 2, 3, and 4.5. And you can graph decimals because it's just in a sketch. Okay, it's approximation. So down over 3, 1, 2, 3, and we can use the scale this time. 9.5 is going to be down here. It's a 10 by 10 grid. So there's my vertex. It says over 1 up a half. So be right there. Back to the vertex, over 2 up 2. So it'll be a half, so it'll be in there somewhere. And finally over 3 up 4.5. So a half, 1, 2, 3, 4. And due to symmetry, we know where it is. There we go. We have graphed, sketched by hand, a parabola that was originally in standard form. Okay, so it's just combining what you've done the last couple of days. All right, there's nothing new here. Okay, we have done, I'm going to write on this, you don't want to do this to yours. We've done this on this side. Okay, that was a separate day of how to complete the square. We've done this. Okay, this was just graphing when it's in vertex form. So now this is the final product. We're going from start to finish. You get to see the whole thing. So today's homework allows you a little bit more practice on completing the square because you do need to be able to do it, especially for those that are looking at taking the college tech course. If you have any questions, please make sure you ask. I'll clarify. And we'll see you in the next video.